Today, we are focusing on probably one of the biggest variables in apparel development, but maybe the most guessed at, time.
Right.
You might sketch this perfect garment, check all the fit notes, finalize the fabric.
Everything seems great.
Exactly. But if you don't actually calculate the time it takes to put it together,
Yeah.
minute by minute, stitch by stitch, you might have just, well, designed a financial problem.
That's really the core issue, isn't it? In apparel, time is cost. And that cost isn't just materials, it's the sewing method, the efficiency.
And product developers, they're juggling aesthetics, targets.
Constantly. But they often have to rely on old numbers or just kind of hope the factory figures it out.
Yeah, hoping during production, that feels like a huge gamble. Every seam, every movement is direct labor cost.
It really is. And it leads to delays or cutting corners on quality to hit a price or just lost profit. The tech pack is missing that financial blueprint. So our goal today really is to give you that blueprint. We're diving into 3 key systems: GSD, SMV, and ASCS.
GSD, SMV, ASCS.
Got it. These tools help get rid of that ambiguity. They bring some engineering precision, let you make smarter choices, and really control the design and the final cost.
Okay, let's unpack this. Where do we start? GSD, right? The foundation.
Exactly. GSD. It stands for General Sewing Data. This is like the bedrock of measuring time objectively.
Objectively. How's it different from just timing someone with a stopwatch?
Well, stopwatches are tricky. They depend on the person, the day, if they get interrupted. GSD is different. It's a predetermined motion time system.
Okay, predetermined motion time system. That sounds pretty technical. Break that down for us.
It just means GSD has already analyzed every tiny motion an operator makes. Reaching for a piece, lining it up, placing it, the actual sewing, trimming thread. Each micromotion has a standard scientifically set time value. So you don't time the task live. You define the method step by step.
And GSD calculates the time based on those standard motion values.
Precisely. It adds up the time for the defined sequence of motions.
So you figure out the most efficient way to do a seam, list the motions.
Right. And GSD gives you the base time for that perfect method, done correctly, no interruptions.
Okay, here's the key thing then. GSD measures the method, not the person doing it.
That's the crucial distinction, yes. It's the pure, objective time value of the method itself, the scientific truth of that task, if you like.
Hang on, are you saying the time GSD calculates for, say, a standard French seam? That time is the same, whether it's calculated for a factory in, I don't know, the Netherlands versus one in Vietnam. How universal is it?
It is universal because the time is based on human motion, how far you reach, how long it takes to grasp something. Those are biologically consistent. So if the method is defined exactly the same way, the GSD-based time has to be the same. Doesn't matter where it is. GSD gives you that solid foundation. It is the method defined in time.
I see. So it strips out the human variability, sets a global engineering standard.
Yeah.
Okay. So once we had this GSD base time, this objective number, then we get to the actual cost part. That brings us to SMV.
Exactly. SMV, standard minute value, this is the number everyone uses financially.
The final number.
Yes, the final time in minutes. Factories use it for everything: costing the labor, planning the production line, setting targets, even calculating bonuses.
Right. Okay. And the basic formula, I think everyone needs to remember this. SMV equals GSD base time plus allowances.
That's it. SMV equals base time plus allowances.
That allowances part.
Yeah.
That sounds like where the real world, maybe even disagreements come in.
Oh, absolutely. If GSD is the perfect method in theory, allowances are the factory floor reality.
What kind of reality? Like needing breaks, people getting tired?
Yes, that's a big one. Relaxation allowance, personal needs, but also things like handling bundles of cut pieces, changing threads, maybe some machine downtime, quality checks that have to happen during the process.
All the non-sewing minutes that are still necessary.
Exactly. They're essential for the factory to actually run.
Okay, so GSD-based time is universal, you said. But these allowances, they must depend on the specific factory, the local rules, right?
Yeah.
So they need to be localized.
Precisely. That's where it gets complex. A factory applies its own allowance policy. Maybe it's 20% in one country due to labor laws, maybe 15% somewhere else.
And they add that percentage to the universal GSD-based time.
Correct. The challenge for you as the product developer is making sure those allowances are fair and reflect reality, not just padding the cost.
Right, verifying that.
Yeah.
Okay, besides the allowance policy, what other details from my design affect the SMV? It's not just about motions, machines matter too, yeah?
Critical point. The SMV needs specifics from your design, like the stitches per inch you specify.
Uh-huh.
Higher SPI means more machine runtime.
Makes sense.
Also, the fabric type. Is it slippery? Stretchy? That takes more careful handling time. How are trims handled? What's the quality standard? Even machine setup details like needle gauge.
All those little decisions add up in the final minute count.
Every single one.
So this really moves costing away from just negotiating a price to something more engineered.
That's the idea. Engineered costing.
It gives you, the developer, a way to maybe push back if a cost seems high, but also justify why a certain design feature is worth the extra time or cost.
That's the core value. Why obsess over, say, 0.8 minutes? Because it translates directly to dollars. And you make that decision during design, not months later when it's a problem.
Okay, give us those examples you mentioned earlier, how small changes impact the SMV.
Right, let's take neckline finishing. Say you choose binding instead of a standard rib finish on a knit top.
Okay.
That binding construction method, it could easily add 0.8 minutes per garment to the SMV.
0.8 minutes. Doesn't sound like much.
Per garment. Now multiply that by, say, 75,000 units.
Oh, wow. 60,000 extra minutes of labor. Suddenly, that's a significant cost jump, potentially thousands of dollars.
Exactly. Or think about sleeves. Moving from a simple set-in sleeve to a more complex raglan sleeve, especially on a tricky fabric.
Like a slippery synthetic.
Yeah, that could add 1.2 minutes just for a different sleeve shape. That's a big jump for just one part of the garment assembly.
And what about purely aesthetic stuff like decorative stitching?
Curved decorative top stitching is a classic example. The operator has to slow right down, pivot, reposition constantly to keep the curve smooth and the stitch quality high.
Right.
That single operation might add 0.6 minutes. SMV lets you ask, is this curve worth 0.6 minutes? Or does it push us over our target cost?
Gives you the data to have that conversation, to defend the choice or make a different one based on facts.
Hard data. Facts to discuss with merchandising, with finance. It backs up your decisions.
Okay, so GSD gives us the objective base time. SMV adds the real-world allowances for the final cost number. But there's still this issue of ambiguity, right?
Yeah.
How does the factory know exactly what method we mean when we just write French seam in the tech pack?
Good point. They might have 3 ways to do a French seam. This brings us to the third piece. ASCS, the universal language.
ASCS, what does that stand for?
It's the ABC Seams code system. Think of it as the universal translator, the detailed contract that links your design idea to the factory's exact method and therefore the SMV.
A code system. I get needing precision, but what does a code actually look like? What info does it hold?
ASCS standardizes every possible seam, edge finish, stitch detail with a short alphanumeric code.
Okay.
That code links directly to a specific diagram showing the finished seam cross-section, the stitch type needed, the type of machine, any top stitching.
So like a library code for seams.
Pretty much.
So instead of me writing a paragraph describing the seam in my tech pack, I just put the ASCS code.
Exactly.
And that code tells the factory, the picture, the machine, the method. And critically, they can look up the standard GSD time associated with that specific code.
It cuts out the guesswork entirely. If your team specifies construction using ASCS codes, the vendor knows exactly the method and quality standard you expect. Calculating the time becomes a lookup, not a negotiation based on interpretation.
Let's use that jersey skirt example you mentioned. Make it concrete.
Okay, basic tube skirt. Let's say the design team wants to improve the waistband quality by adding an understitch inside to keep it neat.
Right. Stops it rolling out.
Exactly. That specific method might have an ASCS code like, say, H140-12 plus SC.
Okay, very specific. And maybe we also want a particular finish on the bottom hem, like a surged edge. Maybe code H120-1 plus SE plus BS.
Right. So by adding those 2 specific coded instructions, the understitch and that specific hem finish, you might increase the total SMV for that skirt by, let's estimate, around 1 minute.
1 minute. Seems small again, but defined.
Defined, agreed upon, and costed accurately via the ASCS code before production starts. That 1 coded minute prevents big surprises later. ASCS turns your design detail directly into a verifiable time cost.
Okay, this all makes sense. GSD, SMV, ASCS, they work together. But how do product developers actually use this day to day? How do you get this into the workflow, especially if vendors maybe prefer things a bit vaguer?
That's the practical challenge, implementation. It requires discipline and changing how you build your tech packs.
So the actionable takeaways, what absolutely needs to be on that tech pack checklist now?
You need to go way beyond flat lock seam here. Tech packs must clearly state the chosen seam type linked to its ASCS code. the required SPI. And importantly, any special handling notes needed for that method.
The more detail, the more control via the codes.
Absolutely.
That sounds like more upfront work, though. And development timelines are always tight.
It is more work up front, no doubt, but think of it as an investment to prevent problems and arguments later. A big time saver, actually.
How can teams make it easier to start?
Okay, first, practical tip. Stop treating every single garment like a completely new invention seam-wise. Define a standard set of seams like a seam library for each main product type you do.
Right, so for all our basic crewneck tees, we always use ASCS codes X, Y, and Z for the main seams. What's next? Dealing with vendors.
Yes, this is key. You have to start asking your vendors to, quote, if their quote seems way too low or suspiciously high, you can now have a specific conversation about their base time calculation for that code. It shifts the talk from just price haggling to an engineered cost discussion.
Based on the same defined methods.
Right. And the final, most critical step day to day, track the SMV deltas.
Deltas, meaning changes.
The second you think, let's change this sleeve or add that top stitching, you need to know the SMV delta that change causes. Track those changes through development.
So you always know why the final cost is what it is. No surprises in the costing meeting.
Precisely. You avoid hitting that wall where suddenly the garment is too expensive and nobody knows exactly why.
Okay, so using GSD, SMV, ASCS really tightens things up. Clearer tech packs, less back and forth, smoother sampling, better alignment with the factory on cost.
And ultimately, more control over how the design actually gets made functionally, aesthetically, and financially.
Let's just recap the core functions quickly then.
Sure.
GSD builds that objective, universal base time by analyzing the method motions.
Check.
SMV takes that base time and adds the real-world factory allowances to give you the final cost-ready time in minutes.
Yeah, the financial number.
And ASCS is the universal codebook, the language that precisely links your design instruction to the correct method and its time value for the factory.
It's a vital connector.
So every minute you measure and define with these tools, that's one less problem you'll have to fix later, one less argument, one less hit to the margin.
Or one less compromise on quality.
Right. Knowing the time cost lets you design more effectively and defend your choices with real data.
And, ultimately, the real power here isn't just about protecting profit margins, although it definitely does that. It's actually about protecting the aesthetic quality and the functional performance of your garment.
How so?
Because by making sure your construction vision aligns with a production method that's actually feasible and properly costed, you ensure the final garment lives up to the design intent and the customer's expectation. It prevents corners from being cut just to make an unrealistic cost work.
Protecting the design itself through costing.
Exactly. Which leads to maybe a final thought for you listening. Look at the clothes you're planning for your next season, or even the garment you're wearing right now. Which unseen, minute costing construction detail will you track using these tools to make sure the quality you designed actually makes it to the customer instead of getting lost in a guess?